What's up, pre-calc? Today we're going to talk about function composition, which we have seen before, so it should be a nice little review. But we're going to go ahead and start for our do now by working on evaluating functions in Delta Math. Before I send you off to do that, let's go ahead and go through two examples together so that you're set up for success on your do now. You will see once we actually get into our lesson today on compositions of functions, like why this even matters, why this skill is a helpful warm-up for us. And so let's go ahead and work on this first one. We are evaluating the function. They've given us f of x, and we're looking for f of -1. My first question for you is, this -1, does that represent an x value or a y value? It represents an x value. We see that because our function is literally f of x, and that x has been replaced with a -1 because this is saying, hey, what is the y value where our function f is defined when x equals -1? How we do that algebraically is we're simply plugging in -1 anytime we see an x in f of x. So let's go ahead and do that. So f of -1 is equal to 3. Oh, I see an x, so I'm going to replace it with -1 squared minus 4, and there's another x, times -1. And when I evaluate that, I get 3 times -1 squared. That's going to give me a positive 1. -4 times -1, that's going to be a positive 4. And so my final answer for f of -1 is 3 times 1, which is just 3, plus 4 is 7. And sweet, I think we are feeling pretty confident about something like that. So let's go on and go ahead and do the same thing, but this time instead of giving us f of x in the form of an actual function, they've given f of x to us in the form of a graph. And again, we're looking for the same thing. In this case, we're looking for the y value where our function f is defined when x equals 3. And so I want you to see if you can tell me first, what do you think the answer is for f of 3 given this graph? We're just looking on our graph at an x value of 3. And where is our function defined? Well, if I go up, I see my function is defined at an x value of 3 at a y value of positive 5. And therefore, f of 3 is equal to 5. All right, you're going to go ahead and spend the next few minutes in Delta Math working on our do now. Let's head there now. Great, now that we've gotten our warm-up in, we can go ahead and move on to our notes today over function composition. I'll give us a second to write this down, but the key idea with function composition is that instead of just saying, hey, what's f of 3, right, just plugging some number into a function, I'm actually plugging functions into functions. And there are two types of ways that we can write that with notation. The first way is written down for us here, f, and there's a little circle, g, and then x. How we say this is f following g of x. So f following. And you will see that plenty. Of course, there is another notation that we use, and it is f of g of x. So f of g of x. And it's literally the same thing. Both of these notations mean the literal exact same thing. And so let's go ahead and actually talk about an example. But what you see is that we're just going to be plugging one function into another. And so, for example, 1 part A. I'm going to rewrite this in the notation that I kind of prefer, honestly. So right now it's f following g of 3. I want to rewrite it as f of g of 3. I just think it's a little bit easier for me to understand what I'm focusing on. Whenever it comes to composition of functions, we are always going to start on the most inner function and work our way out. In this case, that means our focus right now, and our only focus right now, is finding g of 3. Because that is my innermost function. I am not worrying about the f right now. I'm just worrying about g of 3. Which I've highlighted and underlined. And so g of 3, we just practiced this, right? We're just going to plug in 3 for x into g. When we do that, we get 3 squared, so g of 3 is 9. Now the key here is that this answer choice of 9, this output for g, is actually going to be our input for f, right? If we replace g of 3 in our original notation, we are now looking for f of 9. F of 9. When we do that, we're just replacing all of my x's in f of x with 9, so 2 times 9 plus 7. It's going to give me 18 plus 7, which is 25, and that is going to be our final answer. F of g of 3 is equal to 25. And it's as easy as that. Let's go ahead and try another one. Letter B. Well, I guess it's letter A now. I guess I messed that up. But this second problem here, again, I'm going to rewrite it as g of f of 3. And I want you to tell me, what is our primary focus right now? Yeah, I really am hoping you were able to say, hey, we are focused on our innermost function, which is f of 3, and that's it. Right, that is our main focus right now. Let's go ahead and find f of 3. Ah, my stuff disappeared. Okay, f of 3. I can't remember what f of x was. Plug in 3 for x. 2 times 3 plus 7. You tell me, what is f of 3? Yeah, 3 times 2 is 6. 6 plus 7 gives me 13. So f of 3 is 13. My question for you now is, what is our next step? What do we do now? Take a look at the first problem we did and tell me, what are we going to do now? Right. Our output for our inner function, right, when we plugged in 3, our output, or what we got out, was 13. That is now going to become our input, or what we are plugging in to our outer function, which is g. And so I'm looking for g of 13. G of x is just x squared, so 13 squared. And we should know this, hopefully, like in our heads, because it's a perfect square, but if not, go ahead and use a calculator, and when we do 13 squared, we get 169, and so that is going to be our final answer. G of f of 3 is 169. Sweet. When we look at this third example, I'll give us a second to write it down. What we notice is that, like, we aren't plugging in a number right now. We see that there is still an x here. And that actually matters for us. That is, the process is going to remain the same, but our answer is going to look a little bit different. Because before, right, when we had a number that we were plugging in, our final answer was just some number, because we were doing a lot of evaluating. What we will notice for an example like this third one, when we're not plugging in a number, but it's still just x, or it's some other, function, our answer is actually going to involve x's as well. And so what this means is my input into f of x is literally going to be g of x. And so if I'm writing f of, what is g of x? Well, g of x is x squared. That means anytime I see an x in my function of f, I'm going to plug in g of x, which is x squared. And so 2 times x, so that means I'm plugging in g of x, which is x squared, plus 7. And from here we will simplify, distribute, combine like terms, all of the good things. This example doesn't really actually take too much from us. It's just 2 times x squared, which is literally 2x squared, plus 7. And that is f of g of x. And again, like I mentioned, we see that our final answer involves like an x variable in it. Let's go ahead and try one more example. This one's a little bit trickier. And so we are doing f of g of x. Can you tell me, are we plugging g of x into f of x, or are we plugging f of x into g of x? We are plugging our inner function, which is g of x, into f of x, which is my outer function. And I see that here in my notation, right? G of x, it tells me, is 2x plus 3. And so I am just really replacing every single x in f with g of x, which is 2x plus 3. And so f of x is x squared plus x plus 1. Well, x squared, 2x plus 3 squared, because I'm plugging in g of x, plus x plus g of x, which is 2x plus 3, plus 1, and that stays the same. From here, you can see this is going to take a little bit extra work from on our part to simplify. And when I'm focused on that 2x plus 3 squared, I think it's really helpful to put that out in an area model because we have to FOIL this, right? I think a lot of us might be tempted to say, oh, like I can just distribute that exponent, so I get 4x squared plus 9, but we cannot forget about our middle terms. We cannot forget about these middle terms. And so when we do 2x plus 3 squared, we get 4x squared plus 6x plus 6x, which is plus 12x, plus 9, that is all from my area model, and that takes care of this, plus 2x plus 3, plus 2x plus 3, which is this part, and then plus 1, which is the last term in my function. Now I can go ahead and combine like terms. Life is good. I want you to tell me, what is f of g of x? After we combine like terms, we should get what I have here, 4x squared plus 14x plus 13. That is equal to f of g of x, which is what we're looking for. This is my final answer. Okay, before we finish and head off into practice, I do want to talk about more practice with, well, what if we're not given a function? What if we're given our functions in the term of tables or graphs? And so let's focus on this first one here, f of g of 1. Again, we are focused on our innermost function first, so I'm just focused on g of 1. And when I look down here at my graph of g, that means at an x value of 1, right? We practiced this in our do now. Where's our function defined? Well, it's defined at a y value of 3. So g of 1 is equal to 3. That means, again, we are now plugging in this output into our outer function. So f of 3. Same thing when we look at our graph at an x value of 3, where's our function defined? And we see here that it is defined at a y, at x equals 3, our function is defined at a y value of 6. And so that is going to be our final answer here. And so f of g of 1 is equal to 6. That would be our final answer here. Again, same process, right? Nothing changes. Just instead of a function, we're looking at a graph. Let's go ahead and do an example with the table. If I'm doing f of g of 1 again, focused on g of 1. So g of 1. When I'm looking at my table, it tells me g of x, so I'm looking at this column here, when x is 1, is equal to 3. My g of x column, when x is 1, those intersect here at 3. And so g of 1 is equal to 3. I want you to tell me, go ahead and do the rest of the problem. What are we doing with this 3? And once we find out what we're doing with the 3, what is our final answer going to be? We're using this output from our inner function. I've said it tons of times, to be our input for our outer function, which is f. And so I'm looking for f of 3. I'm looking at my f of x column for an x value of 3. And we see that we will get 5. And that is where I get my final answer. And so f of g of 1 is equal to 5. All right, we'll get more practice with this, but what I want us to do now, and I'll help you go through this live in person, is a context where we have real world context for a problem with compositions. And so take a look at these notes, and then we'll go ahead and talk about it. Thanks for your work today, team.